Hello everyone, welcome to today's knowledge session. My name is Yash Gupta and I'm software consultant at Noldes. And today I will be your coach for this session. So I'll guarantee you this session will be certain and short. Okay, so don't worry. Before starting the session, let's first talk about the knowledge certificate. The first one is punctuality. It's a very good gesture to be on time that shows you are eager to learn. Second one, keep your windows on mute. Third one, mute your phones and other stuff that may occur the disturbance and pull your attention. Fourth one and the most important, sorry, fourth one and the most important will please give your feedback. It will help me to improve myself. Okay, so the next time I can present better. Okay, uh, let's see what's our today's agenda is. So first, I will be give a little introduction about gRPC. Then why should we use the gRPC? Then I'll tell you what is the Akka gRPC. And at last, I will present a live demo in which I will demonstrate the Akka gRPC. Okay. So let's first start with the introduction. gRPC is an open source framework that starts or introduced by Google, and now it's come under CNCF, that is Cloud Native and Computing Foundation, like Docker, Kubernetes, and all. Okay, so gRPC is a recursive acronym for the remote procedural protocol, remote procedural calls. Sorry for that. So with the RPC, you can directly call the servers method. If we see at a high level, gRPC allows you to define request and response RPC and handles all the rest for you. I will explain how. So basically, you can define protocol for your application to talk to each other. In that sense, you can simply compare it with REST and SOAP, as we know that REST uses the JSON and SOAP with the XML, right? So like that, here we use the protobuf file to send the message from one service to another. Also, the in protobuf file we like declare all the RPC calls and the server details. Okay. So when we use the gRPC, it simply looks like we are calling directly the servers method. Okay. Also, it's modern, fast, and efficient. Built on top of HTTP2, support low latency, streaming. It's language independent. It's a main and like it's an important feature. Also, it's super easy to plug in for authentication, load balancing, logging, and monitoring. These four are very important when we are building an API. Okay. Now let's talk about why we should use gRPC. Okay. So for this example, for this, we can take a very basic example. Suppose we have a microservice architecture in which we have two microservices, A and B. Okay. Now suppose when we want to call the service B from A, we have to make an API, right? Now here's the problem come. Apart from building an API, we also have to take care a lot of things like what will be the data format, load balancing, error pattern, and many others. Sorry. Now, if we only talk about building an API now, it's really hard. I'm telling you, like kind of difficult without the help of any framework. Okay. Now, while building the API, first we need to settle or agree on the JSON, right? What would be the JSON? And believe me, while declaring a JSON or like building a JSON file, it will be hard. Like we have to contain all, or like we have to consider all the requirements. What will be the variables name? What will be their types? And will the JSON will come in a array format or a simple distributed architect? Oh, sorry, like simple distributed type. Okay. So for data models, all we have two uh, JSON and YAML. They are most widely used currently. Now, if we come to the endpoints, see, you are looking at this example. It's a bit complicated, right? We have to uh, like declare a lot of them to call simply one service to another. Okay. Now after that, we have to think about the latency, load balancing, authentication, logging, and many more. Okay. So all I'm saying is that with the help of a framework, you can go from this to this. Okay. So let me introduce to the Akka gRPC, the big elephant in the house. So what is an Akka gRPC? Akka gRPC provides support for building streaming gRPC servers and clients on top of Akka streams and Akka HTTP. So basically mean is that you will get the benefit of the gRPC and you will get the features of Akka streaming to stream the messages. And at the side of the server side, you will get the calls of the Akka HTTP. Okay, now let's talk about its feature. It will provide you a generator that will create your model classes. Like when we are talking about the data exchanges now, like when we talk about calling a method, we use the argument like a case class. So we don't need to create the case classes here. We simply declare the protocols, and the generator will create all the classes for us. Okay. Generator will provide this server API as a Scala trait using the Akka stream source. Now, when we talk about the streaming the message now, so it will give us that Scala trait so that we can easily stream our messages. Okay. At server side, it will give a Akka HTTP route ways to implement all the services. Okay. At client side, it simply gives us the object. If I say in a very basic language, it will simply give a object so that we can directly call their method. Okay. gRPC runtime implements that uses the Akka HTTP to support. So like we don't have to care about the HTTP and HTTPS. Like, okay, we just simply put the certificates and all the keys, and after just declare it in the application.conf and just call them in the method. All done. All authentication is done. Okay. Also, it supports the Gradle and Maven and the Play framework. Also, like Play was already depreciated by the Lightband, so don't worry. We still have the SBT and the Maven. Okay. Any question here? Am I audible now?
Yes, you are
Hello.
audible.
Am I going too fast or it's okay? Hello.
It's fine. It's fine.
Okay. Okay. So let's move towards the demo. Sorry. So here is the demo. Okay. Let's first introduce you with the build.sbt. So as you can see here, as I already told you, the Akka gRPC is built on the top of the Akka streams and the Akka HTTP. So we have to write down all the dependency of Akka HTTP and the Akka stream to put it on the working. Okay. For the test cases, we have to put these dependency, and this dependency is just for the logging. Okay. As you can see that it's calling the logback and the logback classic. Okay. So it's the dependency. Now we have to put the main thing, which is the plugin for the Akka gRPC. This is the currently and the latest version of the Akka gRPC. We have to put it in the plugins.sbt, and after that, we have to call in the build.sbt class. Like we have to always enable a plugin now. So we simply call it here. Okay. Now after that, we have to declare all the protocols for the RPCs, right? So here we are taking simple example. Like suppose there are two services. First one is A and the second one is A. Now first one or the second one is calling the another service and saying only hello by sending the username to it, and the another service respond back with a message, okay, hello username. Okay, so that will be the response from the another service. So as I already told you, you just have to declare a protobuf file that will then the Akka gRPC generator will produce all the case classes, traits, and other stuffs for you. Okay, you don't have to worry. So first you have to create your messages. As you can see that I am declaring a hello request message with a single variable or argument. Okay, so the case class would be for that like this. Case, sorry, case class hello request and name string. Okay, only you have to write this message and the generator will produce this. Also, this protobuf file is a very lightweighted in comparison to the case class. Simply now suppose when we are doing the connection between two microservices A to B, we have to share a lot of things like this are the case classes. Now you have to put it there and there. By using the gRPC, you have to just share this protobuf file only. After that, you are good to go. Okay. Now, syntax would be the Proto 3 because this is the current version. After that, you have to make the Java material files true. Then after you have to declare your Java packages, what will be the path of your package or path of your file. The outer class name, this will be the outest class or the outer class where all the traits and the case classes are in. After that, you just have to like put the sbt clean compile. Okay, now let me go to the terminal and put sbt clean compile. So what it will do, it will generate all the files for you and store in the target folder. Let me show you. See, generator is generating all the grpc files, as you can see that. Let me show you the files. 2.3. These two folder are fixed. Okay. After that, what you give here now, that comes here. See, the package is same. com.example.hello world, com.example.hello world. After that, you declare a trait, greeter service. See here it is, and you declare a method with a RPC, remote procedure call. Say hello. That will take as a hello request as a parameter and return hello type. Okay. So you can see that here. Sorry, in Twitter service. See, a def method hello that takes in as a hello request and returning a future that would be a type of hello reply. Okay. Are we good to go? Hello, am I audible?
Yes, yes, you are.
Okay. So after that, um, the proto file is declared. Now, just you have to implement all these things. Like at the client side, you just have to call them, but at the server side, you have to implement them. Okay. So let's first go in the server side. Okay, in Scala, this is the greeter server. See, this is the main method that you are running on your server. Now, first, after, before that, we have to implement all the abstract method, right? So for that, there is a greater service implementation that extend the greater service, the trait which is generator generated for us, right? Here we have all the abstract method. Now, before that, let me tell you one thing. There are four types of RPC call. Four types. Okay. First one is a simple. That what we call unary. Okay, there will be a simple request and response. There is nothing like that. Okay. Uh, Second one is client streaming. Third one is server streaming, and fourth one is bidirectional streaming. So when we talk about the client streaming now, so we simply send a stream of messages. Okay, we simply send message 1, 2, 3, 4, and 5 and go on. Matlab, we simply send the stream of the message, and as a response, we simply get a single response. Okay, just opposite of that, we call the server streaming. We simple send a single message as a request, and we get a stream of responses or a stream of messages. And when we talk about the bidirectional streaming, we simply send the stream of messages, and in the return, we get the stream of messages. Okay, so uh, here I'm presenting the first one, the unary. Okay, so first we have to implement the method override def say hello, and simply I am giving the very simple definition hello reply. As we all know that The return type is the hello reply. So we need to put it in the hello reply, all the things, and then we have to close it. Okay. So this will be the implementation of the greeter service. Now in greeter server, we just have to make an object so that we can run the class. So first of all, we have to create a service object for the HTTP request. Here we have to simple call the greeter service handler. This will also generated by the generator at the time you declare your protocols for the RPC. Okay. Now you just have to put the system in it to give the context of your current system. Okay. After that, you have to create or run the server. So for that, we have the HTTP from the Akka HTTP and new server at. Before that, it's a new method from the Akka HTTP. See, Akka HTTP is called DSL. Here we have to simply give the IP address and the port number. After that, we have to enable the HTTPS. If you want to enable it, you can enable it. Otherwise, there is no need. So currently, I'm enabling it. Uh, so for that, we have to simply need some certificates and keys, वगैरह. So I already put in the certs, the sources in certs. So this is the certificate .pem file and server one key and server one .pem file. Okay. Now go back to the server. This is all same thing, key manager and all the stuff, key store and all the things. Like we have to give a secret key, okay, to key the store. It's work like a key pair chain. We provided a secret key, it matches it, it encode it, decode it, and then it authenticates it. After that, we simply bind the service. When after that we simply put a on complete method, and it says if it runs successfully, then print grpc server bound to this, it will give the simple IP address and the port number. Okay. So let me start the server by simply just spt run. I can also run it by giving directly the class name, but it's okay. Twitter server now. See, it's asking. There are two main files now in this project, so that's why it's asking. So first we have to run the server. So I enter two. Please ignore the errors. This is from the SL4J logger. I think we didn't. There is log protection. Well, no worries. Let's focus on the main part. See, we got a. So now we are our gRPC server is bound to the IP and for the port number. Now we have to go for the client side. Now for client side, you simply just have to take all take a method. Take the object of the RPC call and simply call the method. So here this client is the object for our uh, RPC protocol. For this data service client, this is also generated with the help of the generator. As I already told you, the protobuf file you need to put at the client side as well as the server side. Okay. And every time you have to generate all the protos for that. So after generating the protos, all the file you will get here as this: the trade file, service client, handler, and the case classes. Okay. So we simply running a actor system, then we have an execution context to run the features call. Or after that, we simply giving the settings for the where our grpc server is running. So when we go in the application.conf file, we have to give some settings for that. Let me go to the application.conf, resources application.conf. So first we have to give the name of the service, which is hello world.greeter service. Then we have to give the host where it is running and the port number. After that, we have to give the authority and then we have to give the certificates and the PEM file. Okay. Now we just have to put it here, all the files. After that, we are good to go. Now we are simply what we are doing here. As you can see that, let me comment out this part, which is no, and also don't worry for that. So what we are doing here, we are simply putting a list of names. Okay. See, as you can see that here, we are a list of Alice and Bob. Okay. So the list will be here. The type of the names will be list of strings. Okay. And what we are doing, we are simply calling for every uh, value of the list. We are simply calling the single request reply method. As I already told, there are four types of RPC calls. First one is unary, second one is client streaming, third one is service streaming, and the fourth one is bidirectional streaming. So we are using here the first one, unary. Okay. So we are simply calling the method for the single request, and in the response we simply get a message. Okay. So what we are doing, we are simply call for the every value of a list, the single request reply. Okay, and we putting the name here, and here, as you can see that the client is the object for the greeter service. Okay, and we are simply directly calling the method. So here is the beauty of the gRPC. Now, if we talk about the REST API, now what we are doing here in the place of this, we are simply calling the endpoint of the another services. Like this will be the object of the another service, and we are call or object of the your framework, and now we are putting the endpoints like API slash v1 slash user, फिर colon उसके आगे name आएगा, then we have to put all the information in this for to get the response. See, this is very easy to implement. Now we just have to run the server, sorry, client, and we are good to go. See, now in the another port, I'm just running the client side. Now we have to run the client. See, first it's a performing request for the Alice, and then performing request for the Bob. These both requests are running on the separate thread, and we got the response from the hello from the server, from our server. See, same response we are sending from the server now. As you can see that here, sorry, in implementation. See, we are sending the same. So, any questions? Hello. So, guys, are we together?
Yes, you're connected.
Okay. So, this is all about the Akka Grpc. I hope you got the point. Any questions regarding anything? gRPC and Akka Grpc?
Hello, Yash. Am I audible?
Yes, yes, you're audible.
Yeah. So you explain gRPC very well. So with respect to the rest you are comparing, so we can roughly say that gRPC is faster than rest, right? But how
In
many?
certain ways,
Yeah.
like in certain, not every time we can use the gRPC. Like if I told you, when we talk about the internal communication between the services, now, so
Yeah.
let me tell you, Google introduced or Google invented the gRPC for the intercommunication between the microservices.
Right.
So when there is a communication between us, internal communication now, like A and B are running on a same cluster, and there will be a intercommunication between the services. So we can use gRPC, and it will be very helpful. But when we are like calling another cluster services,
Mm.
are you getting my point?
Yeah, yeah.
So at that point, we need the encoding, right? Because
Right.
encoding is the priority.
Mm-hmm.
So for that we can use the JSON like REST, because the encoding is the best is given by the REST and the JSON format. Also, we can use the SOAP. For that we can we have to use the XML part, na.
Mm-hmm. Yeah.
So like there are certain ways where we can use the gRPC and the REST. Okay.
Okay. So according to our need, we can use that gRPC or RESTful.
Yes. Yes. Yes.
Yeah.
When you
Thank
are
you.
communicating internally, na, like
Mm.
you are simply calling in the internal communication. So you
Yeah.
can, I am guaranteed that the Akka gRPC is the best, because
Yeah.
if the communication is internal, that you don't need the high level authentication and the high level encoding, right?
Mm-hmm. Yeah.
So you can directly put it Akka gRPC. It will
gRPC.
save you more time.
Okay. Thank you.
Any other? Sure. Thanks, Shashank. Any other? Okay, so I guess we can conclude our session. So thank you guys. Thanks for the joining.
Thank you. Yes.
Thank you, Yash.
Over to you, Johnny.
Thank you.
Thanks everyone. Thanks everyone. And please don't forget to give me the feedback, na. It will be very helpful. Thanks everyone. Thanks. Thanks for your support. Johnny, I think we can drop off, right? Hello.